Come on.
I don't think they can hear you.
Come on, everybody. Do I have to raise my voice?
Yeah, you do, Wayne.
Let's grab a seat, everybody. Come on. It's time.
Gotta get ugly, Wayne.
Hmm. Thank you very much. Well, I want to congratulate everybody for finding the January Homebrew Robotics Club meeting. Okay, you're all to be congratulated. Let's give ourselves a big round of applause. I also want to thank our people at Google for making this space available. It is a huge help. Lots and lots of clubs basically fail because they cannot find places to meet. So being able to have access to a facility of this high a quality is a real privilege. And I just want to say thank you on behalf of the entire Homebrew Robotics Club for that. Okay, my name is Wayne Gramlich, and I am the president of Homebrew Robotics Club. Um, how many people is this their first time here? Excellent. That's just excellent. Okay. Um, Homebrew Robotics Club is in a bit of a transition right now. We now have bylaws, and we're in the process of building up a membership roster. There will be dues in the future. It's because we're a big, successful growing club that we have to do this. Okay. So we had our first executive committee meeting last week. We voted in a preliminary budget. The budget for this upcoming year is going to be about $800. That's $500 to get the bank account started. Okay, so most of it is just, keeping the bank happy. And then the rest is about $100 for the web hosting company, which I believe is GoDaddy. Another $100 for doing badge stuff. Badges are in transition. Watch this space. Okay. And the remaining $100 is some money to have a little more presence at some of the events that we go to, like Maker Faire, Robo Games. Some of the hopefully we'll be able to go to one of the first competitions, things like that. So we'll be voting the budget in next meeting. Okay. In addition, we have to build the roster for the club. Okay, so next meeting we're going to be handing around basically a sign-up sheet. Okay, and everybody that signs up on that sheet will become a member of the club. So that's how it works. So officially, this is kind of weird. There's only 5 members in the club, and that's the executive committee members that most of you voted in last time. Okay, during the Thursday meeting. The November meeting. Okay. Just so you know, we talked it over in the executive committee meeting, and we're leaning towards basically having something called a family membership. So a family of, and their kids can all join for one fee. If your family is of size 1, well, you don't get any cost benefits there. But it's basically everybody joins up under one membership fee, which is the family plan. Okay. And then lastly, we'll put this up for approval of the club. We'll probably have, and this will be at the next meeting. We're going to vote in our dues fees, and it's currently we're leaning towards $10 for this year. Once we get the bank account started, we probably won't have to charge quite that much money for dues. Quick show of hands, for how many people would $10 be? Is $10 okay? Yeah, that's kind of what I thought. Yeah, it's okay. Yeah, okay. So we probably won't throw you out of the meeting if you don't pay your dues. Okay. So the format of the meeting is we start with robot club business, and that's basically over for now. Then we do show and tell. And then at 8 o'clock, we start our presentation. And when that wraps up, we do something we call random access. We just walk around and talk to one another. And at 10 o'clock, we have to clear out of here so that everybody can go home. If you want, we can talk even further in the parking lot, but it's pretty cold tonight. I'm not going to stick around very long. Okay. Is there any other sort of club-related news that people think we need to talk about now? I didn't think so. Okay. What? Oh, one more?
So Google is fine with hosting this every month. We just might not always have this space. So please make sure you check on the website and the mailing list where that month's location is before showing up here, because last couple of months we were actually 2 miles away at one of our other buildings. And just depending on availability, we might bounce back and forth. Usually a few weeks. I've been trying to get them to commit for the February date, and they just didn't for some reason yet, but they will soon.
Okay.
Thank you very much.
Thank you again. Thank you so much. Okay. So we're going to do the show and tell next. So I see a fair number of robots around. So who wants to go first? Shiloh? They've got set up. Who has a robot that they can do immediately? Okay, so Tony? James, okay.
Hi, my name's James.
Very directional. You have to sort of shove it in your mouth.
My name's James Bowman. I'm a developer with Willow Garage. We've got a few things to show tonight, but just quickly, I wanted to give this an outing. It's an Arduino with an Ethernet board, which is plugged into a ROS master running on this laptop here, which is up on the screen. And what is running on the Arduino is enough code to talk to ROS. So ROS is a robot operating system, and it's a message passing system. So what we've got here is a single node running on the Arduino, which is receiving messages from ROS. There's a process, a Python script running on the laptop here, which is blinking this LED. And at the same time, it's passing messages back to the ROS master running on the laptop. This is what those numbers are. It's just reading noise off its analog pins. So we've got messages going from this node to the ROS master, and from the ROS master into the small node that's running here. So it's the beginning of something, right? You could imagine having your control loop and motor drivers running on the Arduino, and all of the smart stuff happening back on the ROS node back at the base. And those guys communicating over Ethernet or Wi-Fi. And so putting the intelligence back on some remote machine. That's all I got.
So, oops, it's not trip. Who's next? Okay, we've got somebody back there. Come on down. You'll come next after that. And please bring the robots all the way over here so that the camera people don't have to go. No, go. You're next.
This is not an autonomous robot this time.
We come bring it a little closer here so that the camera people.
This is my name is Ari Krupnik. My name is Ari Krupnik, and I build radio control gadgets. So this is an iPhone, and you can do that. And this uses standard radio control modules and standard radio control receivers. This is off the shelf. This is off the shelf. A different module. A different memory setting. And anybody who wants to come drive this, come see me after the meeting.
Very good. Who's next over there? I think somebody brought a hero. Who? Oh, please come on, come on. You can go next.
Thanks. Hi, everybody. Is this working?
Very direction. You have to sort of point it at your mouth.
Oh, okay. Can you hear me now? Okay, my name is Wes. I have here a little Bobot that I've kind of modified, and I'm going to go for the Phase 2 challenge. Knock the can off the table, right? Oops, I stepped on that. I'm stuck.
You're stuck.
Yeah, I stepped on duct tape.
Oh, okay.
Hopefully it'll work. We have a ping sensor here that should detect the object and then steer the Bobot towards the object. Once it detects the object, that may not work. It should detect the edges of the object so it can line up perfectly. We'll see if it works. Not quite. Well, yeah, let's see. We'll give it a chance here. I think it's deal.
Usually we blame batteries.
Yeah, that's it. Couldn't be the software, I know that. It's the lighting. It only moves a little bit at a time. I have trouble getting this guy to go straight, so I just move a little bit at a time and then recheck. Does a little dance. Nope, I guess not.
That's excellent. Thank you, Wes. Okay. We're going to do Shiloh next, and then could the gentleman who's going to bring the robot, is that Alan? I can't see you. You can start bringing it forward, okay? Thank you.
And if you could try to use this left table, and then really hold the mic so it comes out on the video.
So, grab it like it. You have to point it at.
Yeah, okay.
You get out of the way.
Okay, so was it November or so? Some of the Google guys were showing off Cellbots, which is Python-based code running on a cell phone, an Android cell phone, controlling various robots. And so that got me kind of excited for doing something around that because Shiloh is learning to program in Python. And so anyway, I've been looking at what's wrong?
The wheel directions are backwards.
Oh, just turn yourself around. Okay, well, fine. Anyway, well, we'll move the wires around. I tore the robot apart earlier today, and when I plugged it together, I must have plugged in the wires in the wrong ports. But bad, Daddy. But anyway, so anyway, that was a couple of months ago, and it got me started down the path of looking for Android devices. So anyway, this Android device, of course, I'm going to hold up the robot, so you can just hold that up and show people what it looks like. That is Arcos 70. It's a 7-inch tablet. Okay, I'm going to set it down. And we're just running a stock application from Lego that uses the accelerometer in there and uses Bluetooth to talk to this. But we've also been able to get Python scripting going on that, and we're in the process of learning to program in Python and in Android to control a robot. And we have an XV11, and I have to say I did let the XV11 clean half the house before voiding the warranty, but. But anyway, the long-term plan is to get an Android phone mounted on an XV11 and all that. But this is, on the way. And this is actually a kind of a nice-sized thing for programming with. And I found a little Bluetooth keyboard that you can use for pumping in
by the.
Keys are in funky places.
Yeah, but it's better than no keyboard at all. So anyway, what? Yeah. Oh, yeah. What'd you say about the keyboard?
A lot of the keys are in really weird places.
Yeah. So anyway, that's about it. We're kind of at the beginning stages of starting a new track here with Androids and Python and so forth. So that's it.
Thank you very much. Thank you very much. We're going to do Alan next, and then Tony next after Alan, and then you'll be next after Tony, okay? Come on over.
So I have two things to share. My name's Alan Fetterman. First is I've been studying Leonardo da Vinci, looking at his drawings, can you hear me now? Looking at his drawings and then actually building the machines. And you might find, for those of you who've done this, sometimes if you build exactly from the drawing, the machine will not work at all. What I like about Leonardo da Vinci is you'll see a drawing of a trip hammer. Then you'll see a drawing of a worm gear. Then you'll see a machine that combines both to do something else. So he was doing object-oriented programming with modules 500 years ago, just that we didn't have that terminology. So I'll demonstrate some of these things. So this is what's known as a file carver. So it combines a trip hammer and a translational screw, and I guess the purpose is to chop marks into a file. And then he had a drawing of a machine that he called a screw duplicator or screw maker, and it's sort of a design for a, predates the screw forming lathe. My materials do not permit cutting, but I have a pencil in there to duplicate the effect. So how this came about is I went to the Tech Museum and saw their exhibit on Da Vinci, and I was looking at all these mechanisms and saying, this really means something. I couldn't figure out. It was like that scene on Close Encounters of the Third Kind where he's scooping up potatoes and saying this means something. Don't know what it means. Eventually, what I figured it out, the reciprocator mechanism that he uses to convert continuous rotation into back and forth is basically the rocker bogie mechanism that you use to level a Mars rover. It's just an inversion of that thing. So basically, anything we know that we need to solve mechanically has been done 500 years ago, and we just need to go back to sort of re-examine that. Talking about Retrotech, Camp swapped me this for, I don't know, he probably got better of the deal. What did I give you? Fairly nice PWM module. Dennis Burke. Okay, thank you. And this is actually a working Hero 1. I'm not going to demonstrate it, but it's kind of interesting. It does work. It talks. What does it have in it? It has locomotion. It has a rotation sensor on the wheel. It has several sensors, a sonar sensor, sonar ranging sensor, a infrared motion detector, a light detector, sound detector. It speaks, it interacts, has an interface, and it actually has a serial interface, 9600 baud, 7-bit, odd parity, one-stop bit. And since it's tokenized basic, if you try to use PuTTY, the characters are all in Cyrillic. So it's kind of interesting to attempt to program it. And you don't have a program editor, so you have to be a really good typist and really patient to get it to do things. So, I think with just a little upgrade, we can put a ROS node on this, right? It's a 6808 processor with, I believe, 2K of memory. So
No problem.
Upgrade to get it to work on that. Thank you.
Okay. Thank you very much. So, Tony next. Then that gentleman, I don't know your name yet, but we'll get it.
Okay, so as you know, PR2 is very cool, but it's also very expensive. So Nathan and his company have been kind enough to provide us with a ROS platform in disguise that costs only 3 orders of magnitude less than a PR2. So what I have is a Nito XB11 vacuum cleaner. And give me one sec here. Come on. Come on, Linux. Oops. Yeah. Yes. Okay, that's what we want to see. So what you see on your screen here is, so I've got the vacuum cleaner on the floor right now. And the vacuum cleaner is great because it's essentially a mobile base and a laser scanner in a box. And if you have a laser scanner, that means you have SLAM and navigation in a household environment or any other indoor environment. And it works really good. I was able to use SLAM on a Nito using basically my laptop, Nito, and a USB cord to map my house. And now that my house is mapped, I can do navigation in my house. So I set my robot down in our foyer, and I clicked on my room, and it drove across the house, avoided obstacles, including the dog, and got to my room and turned into the right direction and stopped. And that is something I'm really happy because that's something I've been trying to do basically since I got started in robotics. So for over 5 years, we've been trying to get something like that. And now we have that in a low-cost platform, at least relatively low-cost platform that you can get in your house. So what you see, and I don't want to disrupt the current SLAM map-making process, so that's why I'm not going to pick the robot up and show it to you. I'll show it to you after the SLAM process. What you see on your screen right now is the SLAM map that's in the progress of being created from the robot sitting behind the podium. So I'm going to drive the robot now, and we should see the map get expanded. And the tool that's on the background, if you see the maps turning now, that tool that's in the background is RViz, and it's a tool for visualizing ROS. Hang on a minute here.
You don't have much
Yeah.
cable.
I'm aware. We're on a short lease of cords and cables right now. Pick up the pace a bit here.
And for those of you who do not know what SLAM stands for, it stands for simultaneous localization and mapping.
So you can see that's the map on the screen turning on the right-hand side of the screen. And in addition to doing localization, I can also do navigation. And I'll give you sort of a crude demo of navigation very quickly. Right now on the internet, there's a driver for the Nito that you can download. And if you configure, you write a couple of configuration, which hopefully will be on the internet soon as well, you'll have an out-of-the-box platform. You just plug it in and install ROS and go. Of course, you do need Linux. What I did was I made a USB stick with Ubuntu on it and just installed ROS on that, so I don't have to install on my hard drive. Come on. Okay, so this is what navigation looks like. It won't entirely work because it doesn't entirely know where it is. But if I make it go forward, it should go forward. Okay.
Sorry.
Yeah, it'll be okay. It'll run over the cable. All right, so that's navigation. And if I zoom in here, what I see on the screen is that's base laser link. That's a fixed map. And that blue is the cost map around the robot. So if you put something behind the robot, hey, Wayne, can you step behind the robot? You can see Wayne. You should be able to see Wayne moving on the cost map. He's right at the back of the cost map there. That's Wayne. So, so that's basically navigation. And if I clicked behind Wayne, it would avoid Wayne. So that's about it, other than showing you the physical robot.
Okay.
So this is what the robot looks like, just FYI, if you didn't see the talk last week. Yeah. Yeah, yeah. I'm using it with Gmapping. Yeah, yeah. I'll talk about that offline. There's a, yeah.
Yeah, we do have to keep the pace moving
Yep.
along here. So
Sorry.
very good.
Thank you.
Next, who's going to follow this gentleman? Okay, we're going to do you. Okay, you're together. Then Camp after this gentleman. What's your name? Could you slide over here? It works.
I need a plug though. So,
We need a plug.
so I'm gonna use that one.
The plugs here too.
Okay. Maybe I'll move over there.
Cool.
Okay, Julie. Yeah, let me get this out of here. Okay. Second part. There's a plug right there.
So my name is Andrew. Ooh. Okay. My name is Andrew, and I've been coming here for maybe 2 years. So this is, I guess, one of my experiments with RoboRealm, which is basically a way to experiment with computer vision. They have just modules that you can use, like fiducials, and you can do, I guess, image processing using this program that comes for free by trial. Anyway, what I'm trying to experiment with is, I guess, the fiducials, which are basically just patterns that are unique, and I tie them to different physical entities. Like this one I'm making as the robot. This one is my ball, and this one's my goal. This is basically a half table bot challenge. Sorry, my camera doesn't have that much space. Anyway, when it should run, I first have the robot just look for a spot behind the ball that leads it all the way to the goal. So like this line over here, the robot should try going over here and then pushing the ball toward the goal fiducial. We seem to be having battery problems.
We'll pause while he deals with battery problems, and we'll do the next speaker in line here, and you can try and figure out your battery problem.
I don't seem to have DVI.
Okay, so is it working? Okay, so sorry. I'm Melanie Wise, and this is Tully Foote, and we work at Willow Garage. We're software developers for Ross. Sorry. Oh, sorry. And what we've been working on recently is we're trying to make a sub $1,000 robot. We're calling it the TurtleBot. If you know Ross, we have an obsession with turtles, and basically it's your standard iRobot Create with some laser cut platters on top of it, a sub $500 computer or around $500 computer, and right now we're using a PrimeSense, but in the future we plan on using a Kinect camera. So Microsoft Kinect, everyone's seen it. And what we're doing with that is we're faking laser data, and we're doing navigation. And Tully's going to talk to you about that while I drive the robot around.
Yeah, sorry. Apparently, I'm not getting the DVI input working, and I don't have VGA on my machine.
Oh, this one here?
Does this not work?
No.
Okay.
There you go. Does it need to be over here?
Just on the floor, under the table, or driving around up top.
Right here is, it's going to be hard for most people to see, unfortunately. So.
Okay, awesome. So we've tried to make some cool tools for this robot, including a dashboard and other things to help you debug. It's kind of like a small version of the PR2. Most of the software that we use on the PR2, we also have the ability to use on our little TurtleBot, so there's a lot of portability. We did the same thing for the NXT robot also, if you guys saw that. And so we're just trying to make robots more accessible and give people a chance to really dig into ROS and use it and have fun with robots. And hopefully you'll be able to see Tully's screen, and that'll really add to the experience.
Well, we can.
This is just a dual-core netbook. Basically, it's nothing fancy. We're going for as cheap as possible. Exciting. And of course, your standard joystick, because no one wants a robot that can't drive, right? But it also drives autonomously. Big bonus.
Just turn this around. See the camera?
Okay. Let me just try it.
Yes, it's completely open source, and we would love you to download it.
It's also the topic of tonight's
Yes,
talk. So
ROS for the rest of you. Yes, no? Oh, hey.
Oh, I just don't see it.
Well, you can see yourself up there.
Awesome.
Yes. All right, we are about to rock out. Tully?
I think I can talk. Can you guys hear me here? Okay. I cannot see my mouse.
Middle of the screen? Yeah. Yes, terminal magic, everyone. Terminal magic.
Yeah.
What are you trying to type?
Create, bring up, laptop.launch.
Maybe.
Bingo.
All right, Arviz.
So, what we have here is the robot. It's basic. Melanie described all the features to it. And I can quickly show you our dashboard. It is also not liking this resolution. Well, won't waste your time now. I'll have it over on the side, and anyone who wants to see it after the talk can come up and see me. I've got the dashboard. You can see the laser scans. You can see the obstacle map. On the laptop, you can give it a command to go to a specific location like Tony was talking about. And you can see it building maps and everything else. So if you come by afterwards, you'll be able to see it. But yeah, this is official announcement of TurtleBot in public, and hopefully it'll be available soon as a kit for people to buy and then start hacking on.
Okay, now we're going to be continuing from our battery problem.
So one of the biggest problems was trying to figure out how to get the robot to get behind it without hitting the ball while going straight to that point. And I determined that by finding the correct place behind the ball and 2 places 90 degrees away from that, and figuring out to go to those first like, as a waypoint, then going to the place behind the ball so that it can hit. Thank you.
That is seriously cool. And this is an example of the use of fiducials and an inexpensive webcam.
How much position resolution do you get out of the fiducial? I mean, the position of your robot, how accurately is that decoded from the fiducial? Like you're within a centimeter? Or?
Yeah, it's about within a centimeter.
I'm getting like half an inch with my fiducials at home. Okay, we're going to do John and John next. Okay, and they've had 2 full months to work on the robot, and it has changed. So let's bring her on down. Okay.
It's all remote control, this one, so I'm just going to kind of run it by.
Let me grab the mic. Grab the mic here.
Hello.
Point it right at the mouth.
Yeah, this robot, we decided to use a better, stronger frame and then a better suspension system. And we changed it so it's a solid piece, so it's this one won't break in half and it won't have as many issues as the other ones. This one's getting much better to what we really wanted it to become. You know, it's a very durable robot. And it's ABS plastic and there's Lexan covers on it, so it's very light.
Oh, big T. This is big T right
Big
here.
T.
But it's a very light robot, and it's pretty well balanced. And what it does is it can take quite a bit of speed. It's going to bounce back from it. So it can go over a little more obstacles than it will.
Very.
Then the autonomous on it and all the other things. And then the arms will eventually go up and down. And the body will turn. And
Yeah.
it's going to have eyes. It's going to have a hand. I don't know if you get over there. But yeah, we want to get ready for robot games. It's more of the operator than it is. Work in progress.
Work in progress. Very good.
Hi, my name's Layla, and I'm from Willow Garage. I just wanted to mention briefly that you may have noticed there's a bunch of us here. So Melanie, Tully, and James just gave some demos looking at hobby robots. And we actually really are interested in understanding how we could support the hobby robotics community, and that's why we're here. And we'd like to invite you all to maybe share your thoughts with us, maybe spend, an hour and a half for a gift for us to just talk with you and understand what it is that you're trying to do, what needs you have, and how we might be able to support them using Ross and other low-cost platforms. So it'd be great if you would be up for talking with us. And if you are, just go to the back of the room over there, and there's a ballot box, or talk with one of us here. So Brian is over here, James, Melanie, Tully, Ken, Troy was somewhere in the back, Bianca, Caroline, and Tony. I think I got everybody. So we really do care about this community. We'd really like to learn more about you all. So it'd be great if we could talk with you. All right, thanks.
Thank you very much. Was it in this? What?
Thank you for the chocolate.
No, there's chocolate. Oh, wow. We had a very good show up of Homebrew Robotics Club members at the, I guess, PR2 open house. I don't know what the correct name of it was, but I counted like 10 or 12 of us, so the interest is there. Okay. Let's see. We're getting a little tight on time here. Camp raised your hand. There comes Camp. There was another robot over there that, was it Ralph's?
This is Dave, the funky monkey. That's our own Nick Donald He sold 350,000 of them this year. At the SIG, which meets at the penultimate Wednesday of every month at the tech shop, we've been building something we call the Bug Bot. This is kind of standardizing. Thank you. I don't need a microphone. Okay. Hey, Bill. Okay. Okay, so here's the first draft. Basically, what we've decided on, thank you, is to use the Arduino processor, and we're using continuous rotation servos, and our goal is to build table bots, which then can be turned into micromice. And so, again, we're meeting the SIG, which is the next to last Wednesday every month at the tech shop. Everybody's invited to come on board with this project. This is the HBRC bug, and as you can see, it's going from one end of the table to the other and back. Incidentally, the servo, the past 4 issues of servo, the Scott McComb article with the Arduino, it fell, covers the same basic thing that we're trying to do. Is it still running? It's good. And so he's on the 4th installment of the article. It's Arduino hardware, software. He's doing continuous rotation servos. Don't put your hand under there. And incidentally, if you're playing around with these things, something you might use is the Wyland leash. When you're developing the thing, you tie it to a string so it doesn't take the full fall. Or you could put it on a little box that's 5 or 6 inches high instead of doing the whole thing. But regardless, this is the HBRC bug Rev 1. Thank you very much.
Excellent. To just put in a little more context there, I basically challenged the club to come up with a class for people to get started in robotics, okay? And a number of our members stepped up to the plate, and this is what they've come up with. And the goal you'll see some more posts going on the list, but the goal is to get a class of people going off and building these things to get started in robotics, okay? Okay, I believe Ted wanted to do one. There's still an unclaimed robot over there, and if the person doesn't raise their hand quick, I'm going to have to skip over it. So you want to come next, Ted? Yeah, I got 2. You got 2. I'm going to hold up the robot that's unclaimed and see if I can find the owner.
Okay, so back in 2009, Bob and I went to Japan to go to the IREX robot show, which is the largest robot expo in the world, I guess. While we were there, we saw lots of humanoid robots. And there are a number of people that are doing Robo 1, which is this humanoid competition. There'll be a bunch of people at Robo Games doing it. They have humanoids that are this size that play soccer, they wrestle, they do kung fu. Anyway, Bob and I could not leave Japan without coming home with a robot. Okay. Yeah, it was pretty bad. So anyway, it turns out that this thing is just a big box of screws and bolts and brackets and whatever, and it's a huge undertaking just to assemble it. So it's been one of those things. And then, especially when all the instructions are in Japanese, that's the other problem. I don't speak Japanese. I don't understand it. So there have been a number of people on a message board that have bought some of these robots in Japan and in Europe that have been working on translating some of the documentation and being able to get it up and running. Anyway, with a mixture of these items, we finally have one that works. Oh, okay. Okay.
You can take a
flop while I drive the.
So this is like the 3rd version of this, and it's really cool. And that's why Ted said that we couldn't leave without one, even though it was all in Japanese. When we went to buy it, the lady at the store. So now this is kind of his just walking slowly mode.
Okay, let's make him run.
Now he's going to run.
He can run backwards.
And he's going to backwards. And this has got, these are 22 or 24 degrees, I forget. 22 degrees of freedom. And they're really good for playing soccer. When we were in Tokyo, we were actually playing soccer. There's a soccer kick, which is really cool, another one. And then you can do side soccer kicks, too, if Ted can remember what the, no, that's a backwards. That's a backwards.
See, I'm trying to remember which one I programmed.
Well, that's a hop, which is cool. Oh, and that's just a wave. Yeah. Oh. Whoa. Push-ups. The problem is the remote has like, you got 4 keys, but then you've got 3 other keys, and with the combination of all, you can do all these things. That's why Ted's kind of just picking a key and seeing what he's doing.
Yeah, so that has a programming language that you can program it in, and you can basically play back these pre-programmed moves. And he's got 30 or so moves that I've got in him, and I've spent a lot of time figuring out which button does what. But in true homebrew style, I only got it working today, so I don't even remember half the buttons I've come up with the program. Yeah.
So do the one where he falls down, gets back up. That's cool.
Oh yeah. Okay, so if he's laying, he fell down. This I can do, I think. So if he falls
It's
down,
very cool.
Get back up
So Ted and I goal is for Robo Games is I think we have to have 3, right, David? Okay, we're trying to find a third person for our team, but we're going to maybe enter Robo Soccer. So
yeah, we have 2 of them, and then Bob also has a.
I have a third one, but it's not, or I have a second one, but it's not quite the same size, and the remote's not as good. So, is that okay? Okay.
We can have a what's the brand of it?
It's a high tech.
It's a high tech.
Okay. So that's that guy. Why don't we show him the balancer and then we can move on? So Ted and I, ever since we met, we've been doing balancers, and we just realized it's been going on almost 9 years now. So this is like our second balancer, and he's called Bender, and he is really, really.
Some people have asked in the club, why don't you guys ever bring a balancer around anymore? It's because you've been bringing it around for like 5 years and it's old hat.
Right.
And a lot of newer people haven't seen it, so we thought we'd bring it.
Yeah, well, that's another story. It's bad enough working with him, Like his wife one day, I walked into the office and she says, "How you doing?" I said, "Oh, okay, but I got to work with Ted." And she goes, "Well, I got to live with him." There goes a. Oh yeah, I didn't see it over there. So I don't know how far the cord goes, but he's one of our more stable guys, and we use him kind of as a test bed to kind of qualify new designs that we're doing. Yeah, otherwise he'll fall down. No, but we've balanced 2 balancers, one balancer on top of another one. That's kind of cool. That's on YouTube. We did that in Las Vegas. Of course, that was a good act for Las Vegas. Yeah, we can demo them afterwise. Yeah. What? Oh, okay, real quick. So somebody else can come up. You can tell he's really dusty. We don't dust very much.
Pretty solid, and we can like kick him. Another thing too, that's interesting. That's the old table test.
Oh right.
The table, and it'll lean up into it. I'm not getting that confident here. Why don't you move that way in case it falls?
Here, let me put this guy over here. Okay, go ahead. So yeah, 2-wheel balancing robots make a really good base because they can maneuver around real easily, and we even have one that falls down, gets back up, but we haven't brought him in a long time. So anyway, thank you.
Okay. So, Alex, did you want to bring up your little robot and tell us just it's not working? And then after him, I'll show my robot that is working, but takes too long to set up. Yes. Oh, Bob and Ted, how much did the humanoid cost?
$250,000 each. Oh. Yeah, we bought 2 of them.
Yeah. My name's Alex. This is a robot that I was just working on a image processing for a Ranger. So I was supposed to get this running today so that I could demo it, but did not get enough time to work on the software on this side to take the data from the Ranger. Uh, this Ranger basically provides a it's um, I don't think it's good for your eyes.
Triangulation?
It's a triangulation system, and what it does is it's basically able to do up to 30 frames per second of ranging. Um, right now, it's meant to be used for a firefighting robot application. So the next part will also include some form of a slam inside.
Where's the laser coming out?
You can just point.
I just don't want to put it into people's eyes.
No, but I mean, can you put something behind it that will just, okay, so it's about that high?
Right. It's basically about 90 degrees coverage. I've tried different lenses to get it up to 120, and I do have a lens that can do the 120. It's basically a very low cost device. The whole unit can be built in one piece for maybe $20 or so. Um, and then the output is already RS serial. Currently 115K pod, but you can use higher if you want a higher data rate, or you can use lower if you want to preprocess.
Thank you very much. This is the robot platform I've been working on. It does roll around in my house. The problem is setup takes 10 or 15 minutes because of the way I have to set up Wi-Fi. So it's basically two Bainbot motors, which I have modified to have rotary encoders on it. If you folks have been here a while, you know I Bill Benson and myself, we do something called Robobricks. Okay, Bill Benson is our secretary sitting back there. And so basically we have a string of modules going along here. I've recently become a convert to ARM processors because they're cheap and they're fast and they're roomy on the inside. So no more 8-bit micros for me. I'm giving them up. Okay. So I have a new 8-bit, 32-bit ARM coprocessor board there, and then it's talking to the rest of my modules. One module does dead reckoning. You just feed into rotary encoders, and you tell it the diameter of the wheels, how many ticks per revolution, and the distance between the wheels, and it keeps track of dead reckoning, does all the math, sines, cosines, all that stuff. And then I have a motor controller board, and that's really all that's necessary to do this. These are just casters. They're omnidirectional wheels that I use to provide casting. And then on this side is an iOmega iConnect. I bought this one for $90 at Fry's. I recently picked one up from Staples for $65. And then we've got an inexpensive $20 webcam. This thing runs Linux, and we can talk to it. And what's really nice about it for me is that I can get access to the serial port here. I didn't even have to make a hole in this thing. They had a nice, convenient slot for me to put the cable through. And so that's how I control the rest of my robot, was with a serial cable. And then what I've been doing is the reverse of what the gentleman with the little fiducial robots did. I'm putting the fiducials on the ceiling, and I'm letting the robot run around underneath the ceiling. Okay, and I'm getting very accurate angular positions of sub-degree angular readings, and my positioning is accurate to currently within half an inch or so. And this is with a fiducial that's about 8 feet up on the ceiling. And so the goal is for me to put little fiducials around my house, and then this thing can drive around from fiducial to fiducial. But I don't have that working yet. So I'm going to stop now. Also, the reason why I don't like hauling this thing around is it's got a lead acid battery on it. It weighs a ton. Okay. The rest of the platform is really very light. I'm going to shut up for there, and we'll get going with the rest of the talk. Are there any more robots? Did I miss any? What? What? You came in here like, we're going to have one more late robot. Come on, let's do it now, and then we'll do the talk. And sorry for the delay on the. So, no problem, Stan.
Hi, my name is Rob Harrell. Just wanted to show off my little robot that I made. His name's Sanjuro. I made it with the Nito Robotics wheels, and thanks for the wheels, and an Arduino. So I was just having fun, basically putting all the pieces together because pretty much all this is soldered together by myself. Tabletop robot. Currently, he should be phase 1 compatible. Let's see if he actually will work in front of a crowd. So he's running around. Sometimes one of the sensors can get a little sticky and doesn't move quite correctly, but he seems to be working well now. So, Sanjuro.
I should mention that when Camp brought the wheels and encoders, the next meeting, 3 robots came back using them. It was a record because usually we hand this stuff out, and 90% of the time it never comes back. But this time, a lot of it came back in robots, which is what we like to see. Okay, let's move on to the next phase. Just before I do that, when is Robo Games, Dave? Okay. Yeah. Okay.
Yeah, we're working with David to establish a new robot competition class that would be the cloud-connected robot. So we are trying to figure out the specifics and get that out next week, so you still have a couple of months to build something and compete. But the goal would be your robot has to use a cloud service to accomplish its task.
Great. So, so Discovery is going to cover? Great. Okay. We've always been very lucky with this club that Dave has run Robo Games, and he lets us in by just bringing in robots. Okay. And it's always been just very nice to be able to have Robo Games right here in the San Francisco area and being able to participate. So, yeah, thank you. Okay, we're going to do our talk now. Our very own Patrick is going to talk more about ROS, Robot Operating System, and he's going to use Pi as his robot. And I'm going to hand this over to you. You can use either this guy or this one. Which one's it going to be? He's going to use the one on the desk.
Yeah. All right, well, thanks for coming. And the first thing I need to say that my brain is basically at its sharpest at 4:30 a.m. and it's now currently mush. So if I stumble into total incoherence at some point, just poke me with a sharp stick and I'll probably wake up again. I asked Rose about, well, back in October, if I might do a talk on ROS, and at the time I was literally just going through the first beginner tutorial on the ROS website, and I'd have no idea where I'd be at this point. So, but it turns out the tutorials are just unbelievably good, and there's a tremendous amount. Is that Melanie? They're just awesome. There's no excuse not to try to learn ROS, that's for sure. And and the other thing I got a tremendous amount of help from is just people out there in the world, and one in particular, I just make a shout out to Mike Ferguson at Albany, he's just unbelievable. He's on the Tross and Robotics forums, and we now even have a subforum specifically dedicated to ROS, and he's sort of single-handedly pulled me and a whole bunch of other hobbyists into ROS by being online 24/7 and just ready to answer absolutely any question we might have. The other thing I have to warn you about is the last time I ever gave a presentation, I was still using transparencies on an overhead projector. So I've actually never made one of these fancy presentations before, and I'm using OpenOffice's Impress because, of course, I'm not going to use the other one. And so we'll see how this goes. I think this is how you do it. So this, just for fun, I made this little thing called Wordle. And you can do it with any of your robot pages. I copied the text of my head tracking tutorial into the Wordle text box online. And then it gives you this little picture of all the words with the size being proportional to how often they were used in the text. And of course, you can see Ross got a lot of attention in that particular tutorial. So I'm quickly becoming a fan. One other thing I'd like to say is anytime during the presentation, feel free to interrupt and ask questions. I have no particular need to get through this all or in any particular order. So the title of the talk is Ross for the Rest of Us. And by that I mean Ross really started out in the university world and university labs. Very particularly, I think there was a good chunk of it at Stanford and has a long traditional history in Stanford. And of course, Willow Garage itself has essentially demonstrated it out there in the world at large on their premier robot, the PR2, which is a $400,000 robot, which is out of our reach. So the question to me was, would it be possible to run ROS on the kind of hardware that we use and to do the tasks that we like to do with hobby robots? And so I took the plunge, and it actually took me a little while to make that decision. Partly, it's ROS is only 3 years old. You know, they just celebrated the 3-year birthday a few weeks ago or a few months ago. And I'm not brave enough to dive into something that's just getting going. So I did want to wait for it to come to sort of the Debian package level rather than the level that I had to compile on my own. I am a Linux network administrator by day, so I'm familiar with Linux, but unfortunately I'd slipped into the world of Windows robot programming, which is really, really easy. Everything's done with a GUI. You know, in Visual Studio, you have drag and drop controls into nice, pretty forms. And RoboRealm, as a couple of you have mentioned, is just an unbelievably easy package to use for visual processing. It's a great learning tool. You can drop any kind of filter from edge detectors to Fourier transforms. Even today, they just released, or within the last 6 days, they released an object recognition module based on all sorts of different feature classifiers. So the Windows world is actually a very tempting world to stay in to program robots. But nonetheless, I wanted to take a look. So Willow Garage and ROS, of course, come as kind of a pair. Willow Garage is .com and ROS is .org. And ROS is where all the real machinery gets built for the software end of things, and for where you can go and get pretty much everything you need to know about ROS. And I'll talk a little bit about what kind of resources are on that site and how they can help you get going. So what is ROS? Everybody here knows, of course, it stands for Robot Operating System, and usually they like to insert meta in front of operating system because, of course, it is still running on a computer operating system, particularly Linux. But more importantly, it's a publish-subscribe model in a network-centric environment and provides a set of communications channels for message passing between independently running nodes that control your robot. And for me, the publish-subscribe model was actually rather new. Ordinarily, when you're programming in things like C# or even C++ in Windows or even Python, you tend to just build a program from beginning to end. You can certainly you can certainly segment out functions and different methods and call them, but you tend to, if you want, for example, the value of a particular sonar module at time t to see whether or not there's an obstacle there, you just query that object. You have some object in your code, some class perhaps, some instantiation of the class that represents that sonar module. You just query it immediately. You know what its name is, and you get back the current value. When ROS works differently, and in this case, we use a publish-subscribe model where that sonar module is actually just running on its own in its own little ROS node, and it's constantly publishing its distance value that it's got onto a topic. And it's like it's sitting out there on a message board, and if anybody cares to read it, they can subscribe to that message board and get the data, in this case, the sonar distance, at any time they want. So it's a different model, and it takes a little while. It took me a little while to get used to, but that's where the tutorials really help. And if you just go through them from beginning to end, for me, familiarity sort of breeds an understanding, and by the time I got through the tutorials, it really started to make some sense. By the way, I wanted to ask this right up front. How many people, besides the Willow Garage folks, here tonight are actually using ROS on their robots? Damn, just 2. And how many are at least exploring the tutorials or online? Okay, a few more. That's good, because that's a great place to start. One of the things I like, third point here, is that there's the standardized units of meters and radians. And this may sound somewhat trivial, but how many times have you actually gone into your own code and tried to figure out, how many ticks of the encoder map into how many inches on the floor, or how many, what is the value, the analog sensor comes back with the value of 923 out of 1024. And does that mean it's 72 degrees for a temperature sensor, or does it mean it's 62 degrees, and so on? And so it's nice to have a standardized set of measurements, because once everybody agrees that we're going to deal with metric, or at least deal with meters and radians in this case, then we know we're all talking the same language. It prefers Linux, as you know, and this is probably the biggest hurdle to a lot of people, I think. But let me see, with a show of hands, how many people are actually using Linux. Oh, wow, that's a much bigger show. So it's not going to be a big hurdle. And the nice thing is, for those of you who are not, Ubuntu Linux and others, but certainly Ubuntu is the one recommended by Willow Garage and the ROS community. It's unbelievably easy to install. You can install it right alongside Windows. You don't even have to repartition your disk, and so you can give it a try without taking any risk. And the other thing, that this is what I was referring to earlier, if you spend enough time programming in a kind of a GUI, Visual Studio style application interface device environment, you may find this feels like a little bit of a step backwards to almost like the DOS world, because now you're dealing with command lines a lot, and terminal windows, and text editors, and not so much the drag and drop stuff. But once again, I think once you start getting used to it, you see that this actually isn't such a bad way to go. And there are GUI interfaces being introduced all the time, and we saw Tully, although we couldn't quite see it because of the resolution problems. There's no reason you cannot create, using WX widgets or something like that, your own little GUI interface to your robot. As a rule, people don't seem to do that right away, because it's easier just to type the command on the command line and get going. Right, so WX Python sounds like a good place to make your own, a good tool, good language to use to make your own type of GUI. And then, of course, the two favorite languages for ROS are C++ and Python, and I'm embarrassed to say that C++ still kind of gives me a headache. So but I didn't know Python at all 4 months ago. So I went to the python.org tutorial, and it's again just an awesome tutorial. If you go through the beginning to the end, you know Python basically. And what's amazing about Python to me, and I'm probably preaching a little bit to some of the converted here, is it's like writing in pseudocode. It's you just write it and it works. So I really like Python, and even though it's like the 100th language I've had to learn in the last 20 years, it's one that's nice to use. So you missed the most important one. That warning: ROS is addictive, and it's addictive in a really funny way, because once you get into it, you really kind of start wanting to understand it, and you really want to start using it, because you start getting this weird vibe that this thing is really powerful. And if you don't get through to the point where you're using it, you're going to miss out. So it's a bit of a struggle at first, at least it was for me, but it's a big payoff in the end. So the ROS highlights, what do you sort of get if you make that effort? Well, you kind of get SLAM for free, which is pretty cool. And that includes path planning. And these are some of the things that Tony was showing earlier. And it really is remarkable. And I'll show a quick little video in a moment where you just let your robot run free in your house, and it just produces this wonderful floor plan of your house in about 10 minutes. And then you can tell it to go from anywhere from point A to point B. And I know there's some people in the club that are actually programming this from scratch on their own using particle filters and so on. And that's, to me, that's just brilliant. And that's amazing that people can do that. But if you don't have the time to do that and just want to get to that mapping level, ROS is going to let you do that out of the box. Now, it's not easy to set up, but it is one of the things that you get rewarded with if you make the effort to get there. Another big highlight is visual processing. This is done through OpenCV, and what you'll find with a lot of ROS packages is that they've actually been around a long time before ROS. So OpenCV has been around forever. It came out of IBM or Intel, I guess it was. Was it IBM or Intel? Intel, I think. Sorry, Intel. Back in, pardon me? Correct. And he's at Willow Garage, I think. Back in 1999. And it actually has a very nice Python set of hooks now. So again, if you're a little C++ phobic, did someone over there do the Python stuff? All right. Thank you very much. It was quite a relief when I saw that. Now, it's still not going to be as easy as RoboRealm, not even close. But it's as more people start using the Python version and more people start writing some tutorials, it'll become easier in that regard as well. It certainly is very powerful in terms of extracting visual features from your video stream coming from your robot's camera. Another big highlight is the point cloud library, something that I've barely even begun to explore. And this is where you have a three-dimensional point cloud, either from a scanning laser or now, wonderfully, with a $149 Kinect camera, you can have your very own 3D point cloud on your Create robot, for example, and dive right into the point cloud library. And the point cloud library allows you to do things like segment objects, three-dimensional objects off a table, recognize objects from their shape, and so on. So it's a very powerful tool, something that would be extremely difficult to do on your own. And the nice thing about the Kinect is a very nice anonymous donor actually just gave me a Vidir stereo camera for PyRobot, and that camera was $1,600, and all it is a pair of lenses and it's tied into a chip that does the stereo correspondence. I say all it does, but it's a very difficult thing to do, and it costs $1,600, where the Kinect is $149, and away you go. Another big feature is ARM navigation, and this is a big one because this is one of the hardest things to solve I think, for hobby roboticists, is not so much the forward kinematics, but the inverse kinematics. So if I ask you if I want your robot to have its hand in this position when the current position is here, how do you drive the joints through various angles to make sure that the hand ends up in that position? And that's a really tough program to do. It's actually something I worked on and solved in a minor way for my thesis 20 years ago. But back then we were running neural networks with 16 neurons per network, and it took 3 days to simulate the network with just 16 neurons. So it's a new world out there for ARM navigation. So that's part of ROS. And RViz for visualization. Tony had that up earlier, demonstrating the occupancy grid that he was getting from the Nido. This is a really nice tool, and we'll see a few examples of how you can use it. Player Stage Gazebo are long existing projects, open source projects, and they have been wrapped in ROS as well. I actually haven't used these extensively. They're for simulating, sort of practicing your algorithms on simulated robots and simulated environments, including actual simulated physics. So you can even have things bump into each other. And SMAC, am I pronouncing that correctly? Smash, thank you. Hierarchical state machines. This looks really neat, and it's something I want to play with. And it's basically a way for you to set up a hierarchical set of tasks. And a typical one might be go tidy the living room, and that would be the highest level of the task. And now somehow the robot needs to figure out, well, to do that, first I have to get to the living room. Then I have to start looking for stuff that doesn't belong in the right place and move it to X, Y, and Z, and so on. So you can build a set of tasks using this very nice library that was created quite recently, actually. And then finally, my all-time favorite, and hopefully Tully will appreciate this, is this is actually the reason I waded through all the ROS tutorials, and that is the transform frames. Because when you want to control an arm with any more than 2 degrees of freedom, the math just becomes a nightmare. And to solve those kinematics problems it's doable, and I'll show you how I sort of did it for those 2 joints. But the moment you go past 2 joints, it just becomes a big pain. So it's really terrific that someone spent the time, and that those people who are here in this room, to work it out once and for all. And they use quaternions, which are a way to get rid of the singularities and the ambiguities and rotations. And then you just get to use it for free, and I'll show you how powerful that is in a moment. Now, this is a slide that's particularly relevant to this group. It wasn't too long ago that you couldn't make this list. And basically the platforms that we're focused on first were those that were typically seen in the university labs, like the Pioneers and the Video robots, of course the PR2. But now there's almost no piece of hobby hardware that this won't interface with. And so in particular, the iRobot Create, the Nito, which is actually very recent hack, thanks to Hash79, whose real name I still can't find anywhere on the internet. So he remains a mystery at large. And Mike Ferguson at Albany. And then the Arduino was just recently, the AVR bridge was released, and that's what's going to allow Camp's ClubBot to grow up someday and become a ROS robot as well. And we saw a demonstration of that tonight, where we can blink the lights and read the analog pins. And away it goes. The serializer, I actually happen to really like the serializer. I've been using it for a long time, and it's got all sorts of PID controller stuff on it for doing odometry, so that was terrific. But it's basically just supported for .NET libraries, so I was using it in the Windows world. So I have now a Python library, and then a ROS package wrapped around that. So if you're a serializer fan, that is now fully ROS capable. And then, of course, for Dynamixels, which are the servos that are being used on PyRobot here, you can control them with a USB to Dynamixel. You can control them with an Robotics. The Lego NXT, Fidgets, Lynx Motion, SSC32, and RoboBoard. These are all now supported with ROS packages. Okay, here's where I get away from these bulleted slides, which are kind of boring. This is the basic idea as I understand ROS, and this is what I wrote a little head tracking tutorial that sort of illustrates the various components. ROS likes to break everything down right from the beginning, and I think it's to our advantage as programmers, into nodes. And each node, hopefully, is pretty small in terms of its code base, so you don't get too lost in the details. And in the case of head tracking, if you wanted to head track a visually moving object, the node that ties everything together, we'll call that the head tracking node. But then we need a camera, obviously, so we can see the objects. We need servos so that we can move the head to the position of the object. And then in between the camera and the head tracker, we need to extract visual features. What is it that we want to track? Are they going to be color features? Are they going to be shape features? What are they going to be? And then to separate out the movement commands from the actual physical hardware of the servos, we'll actually have another node that we'll just call movement commands. And that way, if we want to plug in a different servo controller board, we can do that at a later time. So ROS really encourages this divide and conquer strategy by encapsulating everything in a node. The next thing I wanted to point out is that you don't have to program everything in ROS. In fact, that's almost a non sequitur. It's not actually a correct way of saying that, because the code can be almost anything. You can have all sorts of existing code for extracting visual features. You can have all sorts of existing code for talking to your cameras and your servos. And you can then just put a few lines of code at the beginning, at the end, and in the middle that turn it into a ROS node. Because basically, all ROS nodes do is pass messages back and forth to each other. So illustrated here by the green lines. And they pass them on these message boards that I was calling topics earlier, or they can communicate by something also called services that we don't need to deal with right now. But the basic idea is the little yellow circle around these guys is this wrapper. So you can either start from scratch and write in Python with all the bells and whistles that ROS or C++ that ROS has to offer, or you have this existing code that you just want to wrap up. Furthermore, ROS is fully network centric, and that means it doesn't really care where the nodes are. And this is very useful, for example, when you want to run a very small, lightweight microcontroller board on your robot, maybe just for reading the sensors, even a laser scanner as far as that goes, and then you beam that data back to your laptop or your PC where you have all the horsepower to do visual processing and so on. So the red arrow there from the visual features assumes that, okay, we're going to need a bigger processor to do the OpenCV stuff. So we're going to send that over to a new node, which is the master node. And the master node's always running. That's the one you fire up first. And it's the guy that coordinates all the messages passing between all the other individual nodes. The other thing I put in that slide is that the visual processing could be RoboRealm running on a Windows machine. In fact, it could be so very, very easily because if you're a RoboRealm fan, you know that it has its own network socket server. And so you can run RoboRealm on a Windows machine, do all the vision processing from the camera, and just serve up your variables on that socket, read that socket from your Linux machine and wrap it into a topic or a set of topics for the rest of the ROS node network to read. So it's fully network capable in that way. And finally, I don't think this slide is visible here, but ROS has this really cool little utility called RxGraph that lets you, virtually unreadable, unfortunately, but it's just it shows you how all the nodes in this head track. This is the actual graph printed out from when I run the head tracking process or application, and it shows you how each of the nodes in that graph are connected to each other. Who's talking to whom? Okay, so this is just a brief little video showing OpenCV tracking an object, and the point of this, it's using something called I'm comparing OpenCV to my cat, and I'm actually not sure who's better. I think OpenCV actually has a little bit of the upper hand, partly because the cat just gets bored. But one of the things I really like about this cam shift, and the reason I wanted to use this as a demo, is the cam shift operator doesn't look just for normally, for example, in something like RoboRealm, you might do color tracking with a single set of RGB values, and you can give them some ranges. But the cam shift algorithm actually tracks a histogram, and it was hard to see at the very beginning of this video, but I actually dragged my mouse over the green balloon, and it picked the range of green pixel color values on the balloon and plotted it in the histogram that you see below the picture. Anyway, you can see it actually tracks it very, very well. So it keeps the red circle around the balloon. So we started well. We have our camera image, and now we have our visual feature, which is the green color, the green histogram that we want to track. And we're going to put that on a ROS topic that basically defines the center of that region. So really all we need are the XY coordinates of the center of that red circle that you saw. And then in the end, we map those visual coordinates into a set of movement commands for the pan and tilt servos on the head. And so the pan and tilt servos move accordingly. And once again, we have a battle of robot versus animal. And of course, the iRobot is just sort of blindly bouncing around on things. But you can see that the robot obviously is just tracking that same color patch. We no longer see what OpenCV sees here. That was a little hiccup in the servo. And then it gets a little boring. What's that? one of the differences is that the cat is actually following the little ribbon that I secretly put on the back of the Create, because she wasn't really interested in the balloon. So only the ribbon, and there's the ribbon there. Big attack. All right. So that's the head tracking beginning to end, and that's all done with ROS. So getting started with ROS, where's the best place to go if you're interested? Go to ROS.org, of course. And one of the primary links, of course, is getting started with ROS. And I would certainly do the installation. I would recommend Ubuntu. If you're brave, you could try some of these other distributions. You can do it on OS 10 on a Mac. Windows really only has client support, not master support yet. But Ubuntu is really the easiest way to get started. And then run through the tutorials. And I say run through them twice. I did. You don't have to. A lot of people here are a lot smarter than I am. But I found that, again, simply the familiarity. I found that simply the familiarity of the terms really made all the difference in the world. So once you start just thinking about services and topics and message passing in the way that you might think of just looking up a value in an array, it becomes very easy. And one of the things that the tutorial is very good, or somewhere in the tutorials is an explanation of the transform frames using two turtles. And that one can actually turn your head inside out for a little while, but then it actually starts to click, and it's really pretty cool. I'll just name some of these. This, again, is just name recognition, and so if you see them once here, you'll see them again next time you go to the ROS.org site. But ROS comes with a bunch of really nice little command line utilities, ROS launch and ROS run and ROS node. ROS launch is the way you may wonder, how do you keep track of all these nodes that are independently and asynchronously commanding your robot? Because normally one would just run one program and everything goes. And the answer is a launch file, which is just a simple little text file with one line typically for each node that you want to run, but then it's all there in one file. And if you want to change one of the nodes, you just change that node specification in the launch file and relaunch the whole launch file, and it does all the node launching for you. ROS topic, at any point in time, you can list all the topics that your various nodes are publishing messages on, and you can also echo the values of those messages at any time. So it's a really good debugging tool. ROS service does the same thing. Parameter server, we'll just buzz through this. RViz is the visualization tool. ROS WTF is just my favorite name of a command. And then the TF echo monitor and view frames are for sorting out all those complicated transformation frames, especially when you have a multi-jointed arm that you're trying to control. RxPlot and RxGraph are kind of neat. RxGraph, we already mentioned. This is what gives you that neat little connected line picture of the nodes that you're currently running. And RxPlot actually lets you plot a two-dimensional timeline of different values. So if you are curious about what a particular sonar value is really reporting, and you don't want to just look at a stream of numbers going by the screen, in real time while your nodes are running, you can plot it out on a nice graph, and you'll see immediately whether or not there's noise blipping in the middle of it or something like that. Yeah. Yes, I should have pointed it out. In the installation when you follow the installation instructions on the ROS.org site for Ubuntu, you have a couple of choices of which sort of, how much of ROS you want to install all at once. And if you got lots of disk space, just go for the whole shebang. And it's basically a bunch of Debian packages that from that point forward are totally managed by the update manager. So these are part of the very it's only later when you're looking at third-party packages that you tend to need to look outside of that basic distribution. For ARM, I don't know. No, not at this point, apparently. And all those little things I just listed are on this ROS cheat sheet, which I actually didn't catch the first time around until I was preparing this little presentation. I wish I had it a long time ago. So right on the very first getting started with ROS is this really nice little printable cheat sheet. It's got all those basic commands, including the things you can do with them. So because sometimes the argument lists are a little strange. So you can print that out, stick it on your monitor, and you're ready to go. So that was a nice segue into packages. So the way that you get ROS software, it's all open source, as was mentioned, and you can typically get it. Well, you get all the basic ROS libraries, of course, just by doing the initial install. But then you'll find all sorts of third-party libraries that you might want to use for your particular card, for example. And how do we get there? Oh, here we go. And so packages are defined as a collection of nodes that someone's providing. There's a manifest file, and there's a command called ROSMake that will just automatically build all the files in the package that person's providing, as well as any dependencies that package may rely upon that you may not already have. And it'll go out and get them and then install them for you. So it's pretty hard to go wrong there. And the most typical way to get packages is using SVN or Git. And I've used both. I'm more familiar with SVN, but some packages just use Git. So you need to learn a few commands for pulling in these packages. But once you do, then you can update them at any time and rebuild them at will. And if you want to contribute back or even just start your own, and this is what I did, even if you're not, for the first couple of months, I had nothing to contribute, that's for sure. I was just playing. And but I was putting all my code on a Google Code piece of free space on Google Code, which supports SVN. So it's very nice. I use Eclipse as an editor, which has a nice project manager and built in it. Well, you can get an SVN module for it. And what's nice about that is you can sync up your own code repository as you're building code to the SVN site on Google Code, go to a completely different Ubuntu machine, and just SVN it back all to that machine, and you've got basically the same identical code environment. But this is also typically the way that people share their repositories. So before we look at a couple of things higher up, like SLAM, just in terms of some demonstration videos, I wanted to show you this one thing, because again, this is much more appropriate to the hobbyist level. If you don't happen to have a laser scanner, which tends to be fairly expensive, although now with the Kinect, there's the possibility, of course, of doing SLAM visually using essentially a slice of that 3D vision map as a pseudo laser scanner. And I think, again, it was Tully. Was it Tully that wrote a nice laser scan utility, which maps the Kinect output to a kind of a fake, it's not a fake laser scan, but, well, it's fake because it's not laser, but it maps into a laser scan topic, so you can use it in SLAM as if it were. And I guess the only downside is that it doesn't have a huge angle of a field of view. But in any event, before I was able to get a laser scanner, Mike Ferguson at Albany figured out a way to use a panning IR sensor in ROS, and that's all this little video shows. Here we go. Because this is something you could try right away without any need to buy a Kinect or a laser scanner. And so we have a split screen. On the left is the real robot. On the right is the RViz view of the robot. And I don't know if you can see it, but at the bottom of the robot near the front, there's a little panning IR sensor. And as it picks up obstacles, you can see it places those obstacles in the map in RViz. And what I'm doing is giving it little discrete commands to go right there with the green arrow. I say, come all the way back around here. But then ROS and the path planner has to figure out how to do that without running into the obstacles that it's already recorded. And again, that's something you get for free. The planner is doing some kind of a wavefront analysis or something of that nature, and it gets itself around the obstacles. And as it goes, of course, it updates the occupancy map as the panning IR scanner picks up more objects. So here's one of the advantages of having an RViz model of your robot. As you see, even as the robot was completely out of sight, we were able to actually still see the virtual robot and know that it wasn't in trouble. Yes, Tony? You mean in terms of what? How am I getting the odometry? I'm just using odometry. In fact, there's no slam in this at all. This is just dead reckoning with obstacle avoidance. And Mike Ferguson did try to take it that next step and do proper slam with G mapping. And he said there just weren't enough data points per scan. You're only getting 30 data points per second with these IR scanners, and that just wasn't enough to get the registration. Oh. Okay, so now this is real slam with the laser scanner, and what I'm going to show you is a very fast rendition. This is 6 times speed. I was running the robot slowly just because I didn't want it to take out the cats or the walls or anything. So I ran it for about 5 minutes, starting in the dining room, through the living room, into the hallway, and then the kitchen. And then once it was done mapping out that region of the room, I was able, just like Tony was saying earlier, just to point to any point in that room, and it could get there on its own. So, not sure we're seeing it. Oh, there it is. So let's go back to the beginning. So what's important to show here is that the initial map is just blank. It has absolutely no knowledge. And then as it spins around and starts moving about with its laser scanner and detecting obstacles, the black lines are areas where it thinks there probably really is a wall. And the red is definitely occupied, and the yellow is probably occupied. You can see, again, that took place over 5 minutes, so this is taking place only over 1 minute. But within a very short order, it now has essentially a physical map of a dining room, living room, kitchen, hallway, and even a little foyer up there in the upper left-hand corner. At this point, I can now give it a fairly long-range goal. It's hard to see the big red-green arrow that I just clicked, but he was able to come all the way from the foyer back to the middle of the dining room. So. Yes. That's where once there's the automatic Monte Carlo localization, the AMCL, which does localization when you have a map. And then there's G mapping, which is what I was using here, which is actually building the map from the data at hand. And you can save that map and give it a label and use it at a later time. I haven't explored this hugely. You normally give it, if you want to cheat, you pick it up. I think that's called the robot kidnap problem or something like that. So you can pick it up and you can cheat and give it an estimated pose by clicking in RViz with your mouse and sort of telling it where it is. But I'll ask the Willow Garage folks, is the AMCL good enough? If you have a good enough map of the Willow Garage offices, can you do the kidnap robot problem? Cool. So we could combine Wayne's fiducial house with AMCL, and we'd have the whole package. How do I get out of this? Sorry, I don't see this on my monitor. It doesn't mirror it. Okay, so one of the last things I want to talk about is the frame transformation, since this is what got me, what pulled me into ROS in the first place. And so this is frame transformations the hard way, and this is I did it a couple of years ago. And of course, if you want your robot to reach for an object, this is my goal. I wanted it to do head tracking of a colored object, in this case a balloon. And at the same time, I have a little sonar sensor on the head of the robot that gave me the Z coordinate out to the balloon. So now we had the 3 dimensions of the object in space, and I wanted to move the arms into position so it could grab the balloon. So that's the inverse kinematics problem, and I wanted to solve it just for 2 degrees of freedom, and it's been done a million times, and all it requires is high school math. But the problem is it requires a lot of high school math, and you got to do all these matrices, and there's sines and cosines out the wazoo, and I'm not very careful when it comes to these things. And so I probably spent 2 days just randomly changing sines and cosines until till the arms moved in the right direction. It's just because I lost track. So Tully has saved every roboticist on the planet the agony of doing this ever again, and and I'll show you how that works. Oh, but I do have to show that I was at least mildly successful. So this was back in the old days, and it's also just a slide to show that, or a video to show that, yes, you can program robots without ROS, of course, and you can do some fairly complicated things. So this was using C# on a Windows platform and using RoboRealm for the vision tracking, and then using that algebra that I showed you, the matrix algebra that I showed you, to compute the angles at the two shoulder joints that were required to move the arms into position. But by the way, that's when Pi was obviously a little younger. He's a little shorter. And as you can see, it actually works pretty well. And the moment he grabs the green balloon, I have him change tracking to the red balloon. So RoboRealm has a set of variables where you can just say change to a different color. So now he's holding on to the green balloon but tracking the red balloon. And that goes on for a while. I won't bore you with the whole video, but this is my only video on YouTube that ever became popular. And by that I mean just more than a few hits. And the only reason it did, it was really funny, is because it's something I had no intention of doing. I think the title was "The Greedy Robot Wants the wants the red balloon but can't let go of the green balloon," or something. And it was just weird because all I was trying to show is that you could change the attention from red to green in mid-stride. Okay, so you can do, of course, inverse kinematics and arm tracking outside of ROS, but that was with just 2 degrees of freedom. So I've stolen this really cool slide from Tully's, and it's actually, I'm giving Tully all the credit, but of course, because that's the only name I could remember at the moment. But we've also got Eitan and Wim, all three, of course, big names at Little Garage. And this is just a neat little picture because it shows you on the PR2 all the little different frames of reference that you would have to track on your own using some kind of matrix geometry or quaternions if you wanted to know where each joint was relative to each other joint. And you really have to know that if the robot's going to interact with objects in the world. Even if the robot just needs to scratch its nose, it needs to know how to get the finger up to the nose. The first thing you do to make use of the transformation library, the TF library in ROS, is you build a physical or a virtual model of your robot. And this is actually a bit of a painful process because you just edit a big XML file. At least that's the only way I know how to do it. I think there are tools for going from some CAD drawings to the XML file or something similar to it. But in any event, you only have to do this once. So you get a ruler out, and you measure the lengths of the segments of your arms and your head and your servo dimensions, and you put it in. And as you saw, you then get a virtual model of your robot that you can view in RViz and rotate about. But more importantly, here's a portion of that file. It's about 6 times longer than this. But really all it's doing is giving the dimensions of the boxes, in my case, of the base, and the lengths of the links in between the servos. And then this is where all the magic happens. The transformation frame library, the TF library, all combined with one other node called the Robot State Publisher, can then give you the full tree. And I'm going to blow this up into a PDF and just scroll down. Up here is the base link. So the base link is the very bottom of the robot. And you can see here is the base laser joint, meaning the laser on the front of the robot. And we see that there's a link in between them showing that there's a displacement of 18 centimeters forward from the center of the base, and it's not rotated either way. And if you scroll down this tree, you get to see the whole shebang. So this is every joint in this robot, every link mapped out for you by the transformation library in conjunction with your model of your robot. And so once it's done, And now you can know where every joint is relative to every other joint as it moves about. ARM navigation, this is also just brilliant, and I don't have anything of my own to show you. So I'm stealing a little video from Willow Garage, and this is Ion Sukan, and he's demonstrating here how you can do inverse kinematics with constraints, meaning we don't want the arm to run into itself. We don't want the arm to run into the robot. We don't want the arm to run into the table. And this is just tremendous. One of the things you can do with the transformation library is you'll notice the robot's holding a stick and it's pulling it through a very narrow gap. And we do this all the time. In fact, I was thinking about this the other day. Think about when you're using a screwdriver to screw in a screw. You almost instantly project your sense of tactile sensation to the end of the screwdriver. Our brains are just automatically able to incorporate a device, in this case a screwdriver, into the joint map that is your arm. You have no trouble doing that. Well, the TF library does exactly the same thing. So once you put something in the robot's hand, you can immediately just add that as another joint dynamically on the fly, and nothing more need to be done. If I remember right, the TF library itself is a standalone library. I mean, isn't that right? You can use it on its own. I don't know how you do that because I've only used it within ROS. But any of the Willow Garage guys want to answer that? And finally, the point cloud library, again, just something I wanted to point out because it's a big component of ROS. It's a big feature if you get through to learning how to use ROS, and it's just not something I've played with myself, but I'd love to, because this is the whole three-dimensional perception, world of three-dimensional perception. So now instead of just two-dimensional images that we typically process through web cameras, we're now going to assume that we have some kind of scanning laser cloud, or now with the Kinect, you don't even need that. $149, you can have a three-dimensional point cloud, as it's called in ROS, and that simply means that at most points in the image you have a number of values, could be RGB values, but also particularly a distance value away from the perspective of the camera. And in this library, you can do things. First of all, you can simply visualize these objects, as I've shown a couple here, again, stolen from one of the Willow Garage web pages. And 3D feature extraction, surface reconstruction, object segmentation, and 3D object recognition, because 3D object recognition is one of the hardest things to do in computer vision, of course, because depending upon how this hand is oriented, it looks extremely different to a two-dimensional camera. All these projects, they're certainly not done and shrink-wrapped and ready for everybody to use magically, but they certainly have come a long way, and they're there and ready for you to explore. So finally, just I wanted to leave you with a few resources. ROS.org, the tutorials are there. And there are more than just the beginner tutorials. The beginner tutorials get you through the basic concepts, but then there are particular tutorials on the transformation libraries. There's a really good set of tutorials on the whole navigation stack, which is about SLAM and so on. It's pretty complex, but you go through it step by step, for me, 3 or 4 times, and you finally get it right. It really helps to have a robot, or at least a simulated robot, to test it out. And then there are a handful of, one thing I wanted to point out is definitely use the search box on the ROS.org site. It's actually really good. I mean, for example, to get that list of hobby robot type controller cards today, that's all I did. I plugged in Arduino and I plugged in Roboard, and immediately takes you to the package if it exists. And if it doesn't exist, chances are it's not supported yet, at least not in the main repositories. And then there are a number of mailing lists which are unbelievably helpful. The ROS Users is the biggest one, followed by ROS Connect and ROS PCL. And it's because this is international, there's always someone there to answer your question at 24/7. It's just amazing. And then the other really cool forum is the Trosson Robotics forums that many of you may already know about. And in particular, as I said just a few weeks ago, we created a subforum for ROS-specific questions. And the nice thing about that particular forum is it's just us for hobby guys hacking it out without fearing that we're going to make fools of ourselves in front of the real ROS guys. So it's a good place to go. And that's it. Thanks for coming. Well, I want to give people a chance now to get going if they need to go, and then if anyone wants to come play with some, watching it do some stuff, I'll be happy to plug it in and go.
Alan, and then Melanie, and I saw another hand go up. And Sam. Let's start with Alan. Alan, you had a question?
Oh.
Okay, sorry. Sam, did you have a question?
Yeah, how would the slam work outdoors using a nice flat floor, rolling terrain? How would that work?
I haven't tried it. I did take the laser outside my office door once just to see if at least it could pick up a distance value, and it could, and that's the extent of my experimentation outdoors. I could only make a guess. Maybe you guys have tried it, but it is a probabilistic based. To the extent that I understand SLAM at all, it is probabilistically based. So, to the extent that there's some wobble in the robot, for example, it's going to introduce some noise, but maybe not enough noise to throw off the entire localization, or maybe it just gives you a greater probabilistic bubble around your current localization, so you don't know exactly where you are within centimeters, but you might know within half a meter or something like that.
So if you had like a multi-story building, a miniature building with like a ramp, it wouldn't be able to deal with the fact that it had to find the ramp to climb up to the top?
You mean inside?
Well, anywhere, it doesn't matter.
Right.
Just think you have a level thing here, then another level above,
Yeah.
and you have like a ramp that goes from
Yeah.
one to the other. Is it not going to be able to deal with the concept that, oh, there's a ramp that connects this thing at this level up to this level, and the map up here might be different than
Yeah, I think it could. There's actually a whole another package which is very exciting on the Will Garage site called topological navigation, and it lets you glue together a bunch of maps. Exactly. And the other thing you can do is you can store very locally detailed maps and then link them together with either visual landmarks in the house or even outdoor. Coming back to the outdoor navigation issue, you may not want to map out literally every inch of some outdoor environment. You may have some visual cues that are very strong that you can get to within a region of that visual cue, then bring up the SLAM map for that area. Right. Yep.
Give them time.
A lot of this stuff is almost certainly doable. I just don't know.
Melanie, right? Yeah. Okay.
Oh, how long did it take to port the robot to ROS? Gosh, the biggest time consumer for me was making the serializer library because it just didn't exist yet. So if you don't count that, it's probably 2 or 3 weeks. Yeah. And that's with having a full-time job during the day. That's not at Willow Garage working on robots.
Gentlemen in far back.
Sorry, I didn't hear that. Without knowing its IP address? Oh, without TCP/IP. Are there other transport protocols? No.
group in Norway that ran IP on top of carrier pigeons.
IP on carrier pigeons. That was what I got out of that. That's pretty cool.
You and you.
What's your future plans for PyRobot? What's next?
Well, it's funny because I think I just started with the same goal that maybe many of us have, which is I just want a robot that's roaming around the house on its own, doing useful stuff, maybe talking to me once in a while. And it just turns out that's really hard to do. It takes all. I mean, it's crazy just to tell it to go from the living room to the bedroom to retrieve something that you may have forgotten or find the TV remote. When you really sit down and start coding these things, it's just insanely difficult. And what I love about what I'm really excited about Ross is a lot of the really hard stuff is solved for you. And so I was in the process of literally sort of recreating Slam with a MySQL database and all sorts of stuff. And thank God I found Ross before I got too deep into that, 'cause I'd still be doing that. But so yeah, it's pretty basic. My background's actually in artificial neural networks, and so what I really want to be able to do is talk to the robot in a semi-intelligent way and have it learn from its actual experience around the house. So I wanted to learn that we have two cats and that these cats are different colors and they have different names, but literally be able to tell it that. But you need some sort of basic grounding in visual perception, and this again, just this ability to get around without running into things and destroying your furniture, and to recharge when it needs to charge and things like that. So pie in the sky stuff, but now something that's really within reach of all of us. And it doesn't have to be something as big and with arms like PyRobot. It can be like the Create. In fact, I like that kind of model better than what I've sort of hacked together here over the years, because this is big and cumbersome. And if you want to move it around or carry it from A to B, it's not that big, but it's still cumbersome. But if you have something that's nice and flat and modular, you can pull it apart, you can put it in your suitcase, take it home, show it to the folks at Thanksgiving. It would be a lot more fun.
Are you running all the nodes on PyRobot itself, and what kind of processing power does it take?
For 99% of the testing, I just USB it to my laptop, which is relatively powerful. And then, as it turns out, then at some point I put on a dual core Zotac board. It's a $179 mini ITX. It is. I'm blanking. NVIDIA is the chipset for the video, right? Yeah. Is it Intel? Yeah, but interestingly, and this is the problem I found with all the boards. I started actually with a VIA 1 gigahertz from years and years ago, and trying to run any kind of video processing on it really just dragged it to its knees. So that's always the big bottleneck as far as I've been able to tell. But something like this little Zotac board, which is pretty low power consumption, seems to be able to do it. So for the most part, you certainly can run the whole thing on it. But for the most part, I run, for example, the laser scanner doesn't have a USB, a wireless option at all. So you have to run something on the robot to take the laser data. And then beam it back over your wireless G network to the laptop. Cool.
I'd like to thank Patrick for giving us this talk. I would also like to thank all those folks who came from Will Garage to provide backup to Patrick.
Scared the crap out of me.
So thank you very much for coming to sort of provide a support for questions here. I'm sure that more and more people in this club will start using Ross as time goes on. Again, let's get a number of hands of people that are looking at Ross now. So you can see there's some.
I think it went up.
Okay, and I'll start looking at it. I need the arm for it before I'm able to use it. Yes, Melanie.
I just want to make a small announcement for anyone who wants to use Ross. At the end of the tutorials, there's a survey, and I encourage all of you to take it. I read all the comments and I improve all the tutorials that you give feedback to. So please, if you take the survey, please give me feedback, because the tutorials are an ever-growing project for me.
Okay, so you'll be firing up Pi.
Yeah, people just can
So
go and
so
come
so we'll
and
come in and on
there's
random
other robots
access.
that like Tully's robot needed to get fired up.
Okay, so that's kind of a wrap for this meeting. Okay, uh, Michael, do you know whether or not we've got a talk scheduled for next meeting yet? Okay, you'll have to read the mail list to find out what the next month's meeting is. Rose wasn't able to make it today. I think Violet was not feeling so good. With all of that, thanks for coming, and hopefully we'll see all of you at the next meeting in 1 month.